Hello dear students, welcome to my channel. Today we are going to discuss the haloalkane and haloarene and the physical properties of chlorobenzene. So we have started this video. Today's lecture is all about physical properties and chemical properties of chlorobenzene. Okay, so let's start with it. Subscribe the channel right now. So mainly if we are talking about aryl halides, those are colorless liquids. Those are colorless liquids and colorless solids also. They have some kind of characteristic order with characteristics order. You can write down with me. This channel is all about the 15 minutes short videos. Okay. Now we talk about chlorobenzene. Have you heard about chlorobenzene, right? So in case of chlorobenzene, if we are talking about, it is also a colorless liquid. It is also a colorless liquid with a pleasant smell. The smell of chlorobenzene is very pleasant. Its boiling point, BP, boiling 132 degrees Celsius, and it is kind of heavier than water. Chlorobenzene is heavier than water and insoluble in it. It is not soluble in water. Organic hai, no solubility. Insoluble in water. So these are the physical properties. Okay, let's discuss the second point, boiling point, in detail. If we are talking about boiling point of aryl halides, then you must understand that aryl halide, its boiling point depends on the molecular weight. So it will be like that. Okay, so greater molecular weight, greater will be the boiling point. Third, you can discuss melting point. So melting point, remember the point number A. Melting point of para isomer is more than ortho and meta isomers. Para isomers melting point is more than ortho and meta isomers. Got it? What is para? Para means this is your para. Okay. What is meta? Or what is ortho? Ortho is, this is ortho, meta is, this is meta. Okay, the boiling point of para is more because para isomer is more stable. Para isomer is more stable and symmetrical than ortho and meta. Isomers. Okay, that's why the crystal lattice require more energy to break it. Okay, crystal lattice require of para require more energy. That's why its melting point is more than others because of the symmetrical and stability. You can write down with me. Crystal lattice of para require more energy to break. Let's discuss the chemical properties of chlorobenzene now. The next point will be chemical properties of benzene, or especially which one? Chlorobenzene. Okay. So let's start with it. First thing you have to understand why this is coming. So due to benzene ring, the Cl minus atom present in the ring deactivates the ring and make it ortho and para directing. Okay. Cl minus atom present in the ring deactivates the ring. And Cl minus is ortho and para directing. Cl minus is ortho and para directing. So the rate of electrophilic substitution will be slower than that of benzene. Electrophilic substitution is slower than benzene. The electrophilic substitution reaction in benzene is faster than chlorobenzene. Okay. Benzene electrophilic substitution reaction is faster than chlorobenzene. What is happening here? You can write down chlorine withdraws electrons through inductive effect. Which effect? Inductive effect. Due to electronegativity difference, right? And release electron through resonance. And release electron through resonance. So इलेक्ट्रॉन विड्रॉ भी करेगा और रिलीज भी करेगा क्लोरीन. ओके. थ्रू अब समझेंगे इंडक्टिव इफेक्ट से क्या हुआ. थ्रू इंडक्टिव इफेक्ट chlorine destabilize the intermediate carbocation formed during the electrophilic substitution. Formed during electrophilic substitution. So it will destabilize. Okay. Now let's see the effect of it. The reaction number 1 we are going to discuss is halogenation. If chlorobenzene is treated with Cl2 in the presence of Fe, it is more para directing, so it will form this and this plus HCl. Okay, or para chlorobenzenes are formed. Second reaction we are going to discuss is nitration. Second reaction is nitration, in which Cl is with NO2 or HNO3. It will form ClNO2 plus ClNO2 plus H2O. So mainly HNO3 will react. Ortho para nitrochlorobenzene. What will be the form? Ortho para nitrochlorobenzenes are formed. Next reaction will be sulfonation. So there will be a electrophile attack in which chlorobenzene is there is attacked by H2SO4, H2SO4, it will form chlorine, SO3H, sulfonic acid will be formed, ortho and para. Ortho and chloro. So there will be ortho para chloro benzene sulfonic acid. Ortho, this is functional group. Ortho para chloro benzene sulfonic acid. Benzene sulfonic acid. The next reaction will be Friedel-Crafts alkylation. Very, very important. Friedel-Crafts alkylation. In this reaction, what we have to do, bring a chlorobenzene, react with CH3X, chloroform, whatever, in the presence of AlCl3. Presence of AlCl3. This is Friedel-Crafts. It will form CH3 here. Orthopara methyl chlorobenzene. Orthopara methyl chlorobenzene will be formed. Okay. So this is substitution reaction mainly, and due to chlorine, because of the presence of chlorine, it behave as a nucleophile. Nucleophilic substitution also act as a nucleophilic substitution. Okay. So reactivity of chlorine atom in chlorobenzene is very low, and because of the CCl bond in chlorobenzene acquires a double character and resonance stabilize, so more energy required to break a double bond than a single bond, hence lower reactivity. When electron withdrawing groups like NO2, Cn are attached at orthopara position, the reactivity of Cl atom is enhanced and it can be substituted by a stronger nucleophile. Okay, so let's see. First reaction we are going to discuss is substitution by OH group. Substitute by OH groups. In this reaction, what we have to do, this is your chlorobenzene, reacts with NaOH in temperature 350 to 400 degrees Celsius. It will form phenol and NaCl. So Cl will be removed by NaOH only. Okay, so nucleophilic substitution will be takes place. Okay, suppose this compound was like that, vinyl, like that, in the presence of aqueous KOH, it will form, you can guess it, remove the CH, remove the Cl and place OH there. Okay, so NH2 can also substitute it. There's so many other reactions involved, but remember there will be no reaction, especially I should remember that also. Suppose there is given Cl, CH2, CH3. In this case of aqueous KOH, there is no reaction. Remember this case, no reaction. So there are other reactions also which we are going to discuss in next video, like substitution by NH2, CN, OR groups,